volume of a parallelepiped. Do you know what that is yet?
No.
Using the scalar triple product.
Is it like a cube?
It's like a bent over rectangular prism. I did not say I was good at drawing 3D. There's a nice one in the textbook that looks not a lot neater than mine. Much more beautiful in the textbook.
I think if you made it shorter, it'd be spot on.
Sorry?
If you made it shorter.
At the top here?
Yeah. Like
Yeah,
if you-
probably. I want to go like this, right? And I want to go the same distance up and do that. Oh, this one's not horizontal. That's part of the problem. Okay. There we go. Vector A, vector B, vector C.
No, I have to draw it.
Yeah, now you have to draw it.
You did arrow with C.
I'm about to.
Thank you.
I want to stand back and make sure it looked approximately like the right shape.
Ooh, I've already got too much. I like that.
What do I know about A cross B? A cross B goes this way,
C? No.
right? This is A cross B. That's its direction. The length of this, the magnitude of A cross B, gives me the area of the parallelogram on the bottom. You agree?
Yes.
Anybody other than Ben agree? A cross B is giving me the area of the parallelogram on the base. That's what this magnitude tells me. Its direction is vertically upwards. If I want the volume of this shape, then I want to get the area of the base and multiply it by, oh man, that's hard to draw. I want the perpendicular height. But the perpendicular height is this height projected across onto there by this angle here.
Oh, we have a direction vector.
I have a direction vector this way, that's actually the right length I want. I've got vector C, and if I want this bit, it's adjacent, I want the cosine of this angle. I'm going to say that again in a moment. When Julia's ready. It's okay. This is the perpendicular height that I'm looking for. To get the volume of this shape, parallelepiped, I want the area of the base times the perpendicular height.
Is this going to be in the test?
Yes, could be. So, area of the base times the perpendicular height. But look, I've already got the area of the base, it's the magnitude of A cross B. And I want to multiply the length of C by cos theta to get the perpendicular height. So the volume I want is A cross B magnitude times the magnitude of C times the cosine of the angle between them. Where have you seen that formula before? Shh.
No.
Okay, 1 minute, one moment. Where have you seen this formula before? Something, something, cos the angle between them. What is it?
Wait, don't write it. It's the cosine rule.
Which, not the cosine rule,
No.
what you said.
The dot product.
The dot product.
That's what I said.
The scalar triple product. It is not ambiguous. I don't need brackets. If I put the brackets here, I'll get a scalar. I can't cross a scalar with a vector. Impossible. I have to do the vector product, and then dot product it with another vector. So it's not ambiguous. It's always going to be done that way. Yes?
Can't you get the perpendicular scale of projection for the length? Maybe?
Oh, yes, but I actually want to use this length.
Okay.
The scalar projection will tell me this height, but I actually then want to multiply by this length already.
Okay.
So this is going to do everything in one go. It's going to give me the area of the base and multiply by the perpendicular height automatically. The scalar triple product will tell me the volume of a parallelepiped. Let me give you an example. We haven't even got to planes yet. Man, okay, let's do a volume. Okay, e.g., suppose I have a parallelepiped. I'm not going to give you these, I'm just going to give you the vectors. If the vectors defining the edges of my parallelepiped thing are 2i plus 3j minus k, make sure I get the pluses and minuses right. B is 3i minus 4j plus 3k, and C 4i plus 5j plus 6k. Suppose those three vectors define the edges of my parallelepiped, calculate the volume. Go. Cross product, then a dot product.
So you do both? Wait.
Do the cross product and then the dot product with the third one. And you, if you like, can convince yourself later that it doesn't matter which order you do them, you'll get the same answer. You might get a negative, so I actually really want the magnitude of this. Can I put another magnitude sign around it, or will that confuse you?
Do the magnitude sign.
The volume might turn out negative because of the directions of the vectors. 5, negative 9,
17 times 6.
negative 17. Then you might want a calculator. A cross B
17.
dot C is going to be
7 times 6.
5 4s are 20,
36.
and it's a scalar. 9 5s are 40, negative 45.
42.
17 times 6, 20 times 6 is 120.
100 what? What are you doing?
20 times 6 is 120. Minus 18, so it's 102. Did I get that right?
Yeah, 102.
Okay.
Well, that's what I got, so I hope I'm right.
Okay, which is negative 127. Therefore, the volume is 127.
Oh, that's what I got.
Wait.
Cubic units, whatever it was.
You know how you said don't put the magnitude because it's going to confuse us? I'm confused. No, I just need to ask. You don't need to rub it out.
I'll rub it out. Actually, you can write it again if I want to. This could end up negative.
Yeah.
It's just to do with whether this one goes that way or that way.
Okay.
It's just the relative direction of the vectors. The volume is the magnitude of this.
Okay.
It's the absolute value of this.
So you don't need to go and find the...
Once you've got this, you go, oh, the volume must be the positive number.
Okay.
The negatives are telling you about the relative direction of the vectors. Yes.
Is A cross B and B cross A the same thing?
You tell me.
No, it's not.
Because it's almost the same, it's just got a negative sign of every component. Just the opposite direction.
And that won't affect the answer because it's a mod.
It's one of the things that will give us whether it's plus or minus, correct. But the volume is the absolute value of that. So maybe I should do it like this. It's the absolute value of that. But you can't just do it in your head. You can go minus 127, therefore the volume is 127. I'm not going to do planes today. I'm going to give you some time to practice that before we do planes.